Good morning, students. In the last lecture, we discussed about the first law of thermodynamics. Today, we are going to discuss about the state variables and the thermodynamic equilibrium. So, what do you mean by these state variables? Thermodynamics is a branch of physics which deal with the study of heat and temperature and the conversion of temperature or heat into the other forms of energy. When the temperature of the system changes, when the temperature of the system changes, the various properties of the thermodynamic system also get changes. So thermodynamics also study the changes happen within the system due to change in the temperature, and for that we need some properties, some variables, some characteristics to denote the condition of the system when the temperature get changes. So we define here some variables which are very important in the thermodynamics to describe the property or the characteristic of the thermodynamic system. What are the state variables? Now, what is state? State means condition. Condition of a system when the temperature get changes, and variable means it can be changed as the temperature changes. The pressure may change, the volume may be changed. So, a state variable are the properties or the characteristics of the system when the temperature get changed. Okay, now what are the state variables? These state variables may be pressure, volume, temperature, mass, etc. Okay, these conditions, these variables can be changed when the temperature get changed. The volume may change, the pressure may be changed, the mass may get changed. So we can write here, what are the state variables? The state variable which denotes the condition of the thermodynamic system when the temperature get changed. So these state variables, they are mainly divided into two parts. Some variables are called as the intensive variables and some called as the extensive variables. So these state variables, they are divided into two parts. Some part is the intensive variables and the next one is extensive variable. So we are now going to see the intensive variable and extensive variable in some detail. This is intensive. What is intensive variable? Intensive variable means the variable which does not depend upon the size of the thermodynamic system. If the system has small area, small size or bigger size, this intensive variable remains constant. It does not change in the size of the system. So, what is intensive variables? Intensive variables are the variables which do not depend on size of system. Now this can be explained on the basis of very simple experiment. This is a container, and in this container, consider this is a thermodynamic system. system in which a gas or a liquid is filled up. Now consider that the whole area volume is A, V, P and M with the mass of this. So when we divide this container into two equal parts, when we divide this compartment or this container into two equal parts, what happens? Which of these variables remains constant and which changes? So when we divide this container, the area get changes, volume also get changed, it comes to the half, but the temperature remains constant. Temperature of this compartment and temperature of this compartment will be same. So this temperature is nothing but the intensive variable which does not depend upon the size of the system, because we consider that when a beaker is filled with some water, liquid, gas, its temperature is T, but when this compartment, this container is divided into two parts, it means the size of the container becomes half. Then also the temperature of this gas or liquid remains constant. So here the temperature is nothing but the intensive variable. So what are the examples of intensive variables? First of all is temperature. What quantities also remains constant as the temperature remains constant? Which are the quantities which remains constant? Density. These are some properties which remains constant and it is does not depend upon the size of the system. It is called as the intensive variables. Okay, now we are moving towards extensive variable. Extensive. These extensive variables, these are exactly opposite to that of intensive variables. What are extensive variables? Extensive variables which depend upon size of the system. What system? System means thermodynamic system which is under the study. So what are the variables which depend upon the size? Means when it is fully full container, then what are the properties, and when we divide the container into two equal parts, they get changes. So what are the variables? Its area get changes, its volume get changes, its mass also get changes. So what these properties, area, volume, mass, they depend upon the size of the system. As the size increases or the size decreases, this area, volume, mass, they also get changed. So these properties are called as the extensive variables of the system, and these two variables are very important to denote, to represent the thermodynamic system. Okay, now we are moving towards the thermodynamic equilibrium. Now what is equilibrium? Equilibrium means when there is no unbalanced force acting on the system. Okay, so a system is said to be in the equilibrium condition when there is no unbalanced force acting on the system. So this thermodynamic equilibrium takes place only when the three conditions are satisfied, three equilibriums are satisfied. Which are these three equilibriums? The first equilibrium is called as the mechanical equilibrium. What is mechanical equilibrium? Mechanical equilibrium means there is no unbalanced force acting within the system or between the system and the surrounding. Okay. consider this is the water fed in the glass. So this is said to be in the mechanical equilibrium if there is no unbalanced force acting between the system or between the system and the surrounding. So when the mechanical equilibrium takes place, this mechanical equilibrium takes place only where there is no unbalanced force acting within the system or between the system and the surrounding. Now, what does mechanical equilibrium means? Mechanical equilibrium means if the pressure within the system and between the system and surrounding is constant, then such type of system is said to be in the mechanical equilibrium. Okay, and when such type of conditions are satisfied, then we can say that the system is within the thermodynamic equilibrium. So now we are moving towards the next part. But what is mechanical equilibrium means? Mechanical equilibrium means if there is no unbalanced force acting within the system or between system and surrounding, so this is the condition. And what remains constant? If a system is said to be in a mechanical equilibrium, then the pressure within the system and between the system and surrounding will remain constant. But if some unbalanced force is come or arises by some reasons, then this unbalanced force vanishes with the time. It gets neutralized with the time. If unbalanced force arises by some reasons, it get neutralizes with the time. It get to the zero value, so we can get a mechanical equilibrium. So what is the conclusion? Every system try to attain the mechanical equilibrium by neutralizing the unbalanced forces, and then we say that these systems are in the thermodynamic equilibrium. So what is the second type of equilibrium? The second type of equilibrium is called as the chemical equilibrium. Now what is chemical equilibrium? Chemical equilibrium is the condition when there is no chemical reaction. When there is no chemical reaction within the system or there is no transfer of matter between the system and surrounding, then such type of equilibrium is called as a chemical equilibrium. No transfer of matter between system and surrounding. Okay, now as we see in the case of mechanical equilibrium, this pressure always remains constant or try to remain constant to attain the mechanical equilibrium. In the chemical equilibrium, the chemical composition must be remains constant. So what is the constant? Here the chemical composition will remains constant. Okay. And if the chemical composition get changes, this system try to neutralize that composition, and then we get the chemical equilibrium. So now we are moving towards the third equilibrium. This third equilibrium is called as the thermal equilibrium. Very simple. What is thermal equilibrium? Thermal equilibrium means when the temperature of the system within the system remains constant, there is no transfer of heat. Okay, so we can say that the thermal equilibrium will take place only when the temperature of the system remains constant. Okay, so as in this case pressure is remains constant, in the chemical equilibrium the chemical composition remains constant, in the thermal equilibrium the temperature of the system remains constant. Okay, now when these three conditions satisfied by the system, then there is a mechanical equilibrium, there is a chemical equilibrium, and there is also thermal equilibrium. Then such type of system, thermodynamic system, is said to be in the equilibrium condition. So to attain the thermodynamic equilibrium, it we need to be the system in the mechanical equilibrium, in the chemical equilibrium, and also in the thermal equilibrium. So today we discuss about the state variable and conditions which is to be satisfied for getting the thermodynamic equilibrium of the system. In the next lecture we are going to discuss a equation of the state in which these state variables are used. So this is for today. Have a good day. Thank you.